Students, welcome to s.mathguru classes. Now our main discussion is Jacobians. Last video we solved some problems. Now we consider the remaining problems. Let us consider one problem. If x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta, show that del xyz by del r theta phi equal to r square sin theta. We have to show this. Now solution is start. So first we consider x r sin theta cos phi del x del r this is r sin theta cos phi, then r is 1, del r 1, then we get sin theta cos phi del x del theta del theta r sin theta cos phi, then sin ddx of sin is sin theta, d theta is cos theta, so r cos theta cos phi we get, and next del x del phi del phi r sin theta cos phi minus r sin theta sin phi, del phi cos phi is minus sin phi, minus we write first. Next y we consider, y equal to r sin theta sin phi, r sin theta sin phi del y del r del r r sin theta sin phi, del r 1 we get sin theta sin phi. Now del y del theta del theta r sin theta sin phi, this del theta sin theta is cos theta, so we get r cos theta sin phi, and del y del phi, this is del phi r sin theta sin phi, this equal to r cos theta cos phi, we get this one. Now last one is z equal to r cos theta given, del z del r del r cos theta, this is cos theta we get, del z del theta del theta r cos theta, this is minus r sin theta, we get this one, del theta of cos theta is minus sin theta, and del z del phi del phi r cos theta, this is 0 because phi is absent here. Now our requirement, this taking left hand side, in our left hand side del x y z del r theta phi, this is del x del r del x del theta del x del phi. By definition of Jacobian we get this, and del y del r del y del theta del y, del phi, del z, del r, del z, del theta, del z, del phi. We get this one. Now this equal to del x, del r. We get this one. Sin theta cos phi. Sin theta cos phi. And del x, del theta, we get r cos theta cos phi. And del x, del phi minus r sin theta sin phi. So first row is finished. Now del y, del r. Del y, del r sin theta sin phi. Sin theta sin phi. Del y, del theta. Del y, del theta r cos theta sin phi. Del y, del phi r cos theta cos phi. R cos theta cos phi. So we get del y, del phi r sin theta cos phi. This is sin. We get sin theta cos phi. This will be sin theta. We get this. And the last row, del z, del r, this is cos theta. Del z, del theta minus r sin theta. And last one is 0. We get this. So from this column we get r common, from this column we get r sin theta common. So this is r common and from this r sin theta common. We get sin theta cos phi sin theta sin phi cos theta. Here cos theta cos phi cos theta sin phi minus sin theta. And here we get r sin theta common minus sin phi cos phi 0. We get this one. Now we expand this. This will be r square sin theta. If we expand, first we consider sin theta cos phi. Sin theta cos phi. Then this into this minus this into this. This into this is 0 and minus this minus minus plus sin theta sin phi. Sin theta cos phi. We get sin theta cos phi. This into this 0 and this is sin theta cos phi. And middle one cos theta cos phi. This one, this is cancel, this is cancel. This into this 0 minus cos theta cos phi. This one. Plus last one minus sin phi. Then this cancel, this into this minus this into this. So we get minus sin square theta sin phi minus cos square theta sin phi. We get this. This into this sin square theta sin phi minus and minus cos square theta sin phi. We get this one. So next we get r square sin theta, this is remain same, and this sin square theta cos square phi. We get sin square theta cos square phi, we get this one, and next this and this cos square theta cos square phi plus cos square theta cos square. So here we get sin square cos square phi, and minus plus cos square theta cos square phi, cos square theta cos square phi, and from this taking minus sign common, minus sin phi common, this sin phi and sin, we get sin square phi, and here we get sin square theta plus cos square theta, we get this one, sin square theta plus cos square theta, we get. Sin square theta cos square theta, we get this one. Cos square theta. So this will be r square sin theta, and from this two, this is sin square theta, from this two cos square phi common, cos square phi if we taking common, here we get sin square theta plus cos square theta, and here sin square phi, this is 1, sin square theta cos square theta is 1. So this will be r square sin theta cos square phi, this is also 1 plus sin square phi, and this will be r square sin theta cos square phi sin square phi, and cos square phi sin square phi is 1. This is 1. Therefore, what we get? Del x y z del r theta phi. This is r square sin theta. This is our proof. Short. Very easy solution. Just systematically solve. Ultimately, answer will come. Consider another problem. If u equal to x, y, z, v equal to x square plus y square plus z square, w equal to x plus y plus z, find j, Jacobian, del x, y, z by del u, v, w. Now solution, I rewriting this, u equal to given x, y, z, del u, del x, del x, x, y, z, this is yz because del x 1, del u, del y, del y, x, y, z, this is xz, del y 1, del u, del z, del z, x, y, z, this is xy. We get these three. Next, v we consider. V equal to x square plus y square plus z square, del v, del x, del x, x square plus y square plus z square, this is twice x plus 0, this one twice x we get, because we are differentiating partially with respect to x, others constant, x is variable, del v, del y, del y, x square plus y square plus z square. This is 0 plus twice y plus 0. This is twice y. Del v del z. Del z x square plus y square plus z square 0 plus 0 plus 2z. This is 2z. And w equal to given w equal to x plus y plus z given. These are w. So we get del w del x del x x plus y plus z. This is 1 plus 0 plus 0 equal to 1. Del w del y. This is del y x plus y plus z 0 plus 1 plus 0. This is 1. Del w del z del z x plus y plus z. This is 0 plus 0 plus 1. This is 1. So we get all the values. Now our requirement this. Now first we find reverse of this, UVW by del XYZ. This one. Then this will be by definition of the Jacobian del U del X del U del Y del U del Z. Next del V del X del V del Y del V del Z del W del X del W del Y del W del Z. We get this one, and this equal to del U del X. This value is YZ. This is ZX. This is XY. Del V del X we get twice X, twice X, twice Y, 2Z, and this is 1 1 1. We get this. From this row 2 is common. We get YZ, ZX, XY, XY, Z, 1 1 1. We get this. Now we expand this. If we expand this, first taking YZ, this is Y minus Z. Next minus ZX, this cancel, X minus Z. Plus XY, this cancel, X minus Y. We get this. And 2 Y square Z, YZ square, ZX square, XZ square, XY, X minus Y. Yes. This will be 2. Here X minus Y we taking. Now we find X minus Y again. From this and this minus X minus Z common, then we get X square minus Y square from this and this, and from this to Z square common, we get X minus Y, XY, X minus Y. We get this one. So this will be 2 minus Z, X square minus Y square. This is A square minus B square formula, X plus Y, X minus Y, and plus Z square x minus y plus xy, this is x minus y, 2 and x minus y, this is cancel common, then we get minus z x plus y plus z square plus xy, 2 x minus y minus zx minus yz z square plus xy, 2 x minus y, next you have to find y minus z, from this and this taking x common, then we get y minus z, from these two taking z common we get y minus z common, we get this, 2 x minus y, again y minus z common, we get x minus z, x minus y minus z, actually this should be z minus x in cyclic order, x minus y minus z minus x, but here we get x minus z, so taking minus sign common, then we get x minus y minus z minus x, this is in cyclic order. But actually our requirement del xy by del uvw, since del uvw by del xyz into del xyz del uvw, this equal to we know 1. But we know this value just we get minus 2 x minus y minus z minus x into del xyz by del uvw equal to 1. So this implies del xyz by del uvw, this equal to minus 1 by 2 into x minus y minus z minus x, and this is our answer. This is our answer. So dear students, this is very nice solution, very easy, very simple. So I hope you are all enjoying with me. If you are all enjoying, then please like this video, and if you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.